Hello and welcome to Lapping Analytics. My name is Jimmy Lapping. I'm a psychologist and statistician with an interest in research in a variety of areas and also AI applications in that kind of research. And while this is a video in a series that is focused on data analysis using large language models. In the previous video, I showed how to perform chi-squared tests, binary logistic regressions, and also the Brunner-Munzel procedure in ChatGPT. ChatGPT, the last free version, version 5. And in this video, I show how to do exactly the same in DeepSeek version 3.2, which is the most recent free version of DeepSeek as we speak. Okay, so as I explained in the other videos in this series, when you use language prompts in environments like ChatGPT or DeepSeek, what you need is, first of all, you need information which is a bit of context on the kind of problem, the context in which the data are created. So in this case, you have 42 independent observations for a response variable A and a predictor B. And so that's the context. In this case, then next you provide the data, which is just two vectors, vector A, which has zeros and ones, and vector B, which has zeros and ones. And then we have a bunch of questions. First of all, 3 questions around the so-called chi-squared test of independence, which is the chi-squared value, the number of degrees of freedom, and the p-value of that chi-squared test. Then we have binary logistic regression, because remember we use A as response variable and B as predictor, so we can, given that both are binary variables, we can perform binary logistic regression. And then we really have a bunch of questions on that. So first of all, a few questions on the point estimate of the intercept, standard error around that, p-value for the intercept, and 95% confidence interval for the intercept. Then we have the same questions about the regression coefficient of B, the standard error around it, the p-value, and the 95% confidence interval around it. And then we have a few questions on the so-called likelihood ratio test, which is it's a comparison in this case between the model that includes the regression coefficient, the regression coefficient of B, so it basically includes predictor B, versus a so-called null model which does not include any predictors, just has an intercept. Then also with the number of degrees of freedom for that test, which is basically treated as a chi-squared test as well. So then given chi-square value with the number of degrees of freedom, then we get a p-value as well. And finally, we get also something for the Brunner-Munzel procedure. In this case, we get the value of the relative effect. I'm not going to explain it in much detail. I have separate videos on that procedure on my channel, but it is a non-parametric estimate of effect size. I will explain a little bit more just in a minute when we get to it. Okay, so this is what I fed to DeepSeek. Interestingly, here it says that it thought for only 9 seconds. So then it gives actually the thought process here. So trying to summarize the information it was fed. What is expected, okay, and then how to work. Results are computed systematically. This is interesting information. And then it gives here the output. Let's go step by step. So by the way, this thought process isn't visible automatically, but you can put the so-called DeepSeek option. You can switch that on, and then you get this kind of text. I find it very useful because this way you can check not only if DeepSeek provides the correct answers to the questions, but also whether it has actually followed the correct reasoning, right? Because it's possible in some cases to get to the right outcome, but for the wrong reasons. That's of course not what we want, because then if you applied those wrong reasons to a different data sets with the wrong rules, then you would probably get incorrect answers. Anyway, this is a bit of thinking. Then it says here, starting here is the output. Let's go step by step. Data summary, again, very useful to see what do we have. Two binary variables, A and B, a total of 42 observations. We have A summarized, so A is 50-50 distribution, half of the sample 0, half of the sample 1, and then B, this is actually summarized for A equals 0 and then for A equals 1. So here you get some useful information already regarding the distribution of A for each B category. Then you get a lot of calculations, contingency table, which is correct. All this I have cross-checked with the same kind of output in R and in Jamovi, and this is all correct. Now we get again, this calculates the chi-square value, degrees of freedom. It is in this case 1, because it's the number of rows minus 1 times the number of columns minus 1. So one thing that is nice about DeepSeek in comparison to, for instance, ChatGPT, is that you get also the answers, you tend to get a little bit more of detail for why it gets to that 1 degree of freedom, which, I mean, especially if you're, for instance, a student and you're trying to get a grip on a specific procedure, well, then DeepSeek it has the advantage that it gives more information, all the steps, right? It can actually serve as a worked example. Interestingly here, the p-value, when I run this in R or in Jamovi, I get a p-value of 0.03075. Here it says it puts a 7 in the end. But it's a small difference, but nevertheless it is a difference. I mean, in the end, it's a difference on the 5th decimal. It may be also related to the kind of rounding that is done on decimals, so that may explain why we have a slight rounding difference in the p-value, but in the end, on 4 decimals, we get the same as we would get in R or in Jamovi or in ChatGPT. In a previous video, I also show how to do this kind of analysis in ChatGPT, and on 4 decimals you also get this 0.0308 as p-value. Then we have a binary logistic regression where we have a number of questions around, first of all, the intercept, which we see the calculation here. This is the intercept, actually. This is when, yeah. And we have the same. Well, the intercept is calculated. Is calculated here. Yeah, it's minus 0.693, and the regression coefficient is also is calculated here with the correct formulas, and what we get here is then 1.3863. So the log odds for B equals 0, and for so this is yeah. First of all, we get the intercept, and then we get the regression coefficient here. Then we get the standard error. So I'm figuring this out as I go, because it's not really presented. That's a little bit of a difference with ChatGPT. In ChatGPT, you get the outcomes in order of the questions that you asked. Remember that we first fed a number of questions 2.1 to 2.4 on the intercept, and then a bunch of questions on the regression coefficient. So I had expected that ChatGPT would work in that order, but as we see here, it first provides calculations for the intercept, and for the regression coefficient, so the point estimates they are here, and then it clusters the questions on the standard errors, which by the way are correct. The standard errors with a whole lot of calculation, but the standard errors that are provided here are the same as you get in R or in Jamovi, for instance, or in ChatGPT, also the same. The p-values are also correct. They are provided here. They are based on, in this case, Wald Z tests. We have point estimates, we have standard errors, so we have Wald Z scores, and then we can calculate the p-values, which are here, and then the 95% confidence intervals are also correct for this data set. Likelihood ratio statistic with a lot of calculation gives the outcome here 4.757, which is correct. And so it has 1 degree of freedom. Yes, this is also again a difference when compared to ChatGPT. ChatGPT provides df equals 1, and that's it. And here it puts between parentheses why it is a df of 1, namely you add only one parameter, or actually it's one parameter in this case is because it's a b is a dummy variable, and of course that means that it's a 0-1 variable, so you add something with 2 categories, and that means 2 categories minus 1 means 1 degree of freedom. And the p-value is the same as you would get in the other programs I just mentioned. Then the Brunner-Munzel test, which is a non-parametric test, basically in which you compare every score every outcome. So in this case on A of the B equals 1 group with every outcome in the B equals 0 group. So that's a lot of comparisons, because you have 21 observations in each group. So the number of comparisons is 21 squared, or 21 times 21. So that's a lot of comparisons. And well, then you can do all kinds of calculations, and then you can calculate it differently in different ways when it's just dichotomous variables. You can calculate it faster, as is done here, and you will see that the relative effect is about 0.667. Now we deal with a very specific case of table in which there is a certain symmetry here. So there are so here it's 14 and 7, and here it's 7 and 14. So this diagonal has the same numbers, and this diagonal has the same numbers. And in this specific situation, the relative effect, if you multiply it by 2 and subtract 1, you get the Pearson's, Spearman's, and Kendall's correlation, which are the same for a 2 by 2 table. And so if you have this kind of symmetry, so in this case I will show it again. If you have where is that table here? This diagonal is the same, and this diagonal is the same, then you can show that the relative effect times 2 and then minus 1, so this times 2 and then the result of that, so the 1.666667 minus so times 2, that is 1. So 0.666667 times 2 is 1.33333, minus 1 is 0.3333, which is in this case the correlation coefficient, regardless of whether you calculate Pearson, Spearman, or Kendall's. For a 2 by 2 table, they are the same. So in this case, you would get a correlation of 0.333. And well, then it gives you a nice summary of these answers. Here I still asked, isn't the answer to question 1.3 approximately 0.03075 instead of, this was a typo, and I wanted to say the 77 that was here. But you are absolutely correct. This is a little bit interesting. I apologize for any confusion in my earlier summary, but still it doesn't really explain why it's different. In any case, on 4 decimals, it's the same as you would get in R or in Jamovi or in ChatGPT. Okay, so this is an example of how to get these basic statistics in DeepSeek. Again, providing a bit of context, providing the data that of course is needed to calculate all those statistics, and then a bunch of specific questions. Why do I say specific? Well, I have found that when you use specific questions, it is less likely that you will get something else than what you were looking for. The less specific the questions, of course, the more room for interpretation you give to the program regarding what you're looking for. So be specific and you will also get more specific output. Okay, I hope you found this useful. As I said in the previous video, I showed how you can do this in ChatGPT, and in the next video I will show how to do it in Claude, which is another AI environment. Have a nice day and hope to see you in the next video.